In this video, we're going to compare and contrast Hive, Pig, and Impala. We're going to take a look at what each tool is, what each tool does best, and we'll compare them line by line. First up, a comparison. Hive and Pig essentially provide alternative interfaces to MapReduce. Writing MapReduce code is pretty tough, and Hive and Pig make it a lot more simple. It basically opens up Hadoop to non-developers. Hive uses a SQL-like query language called HiveQL, and Pig uses its own data flow language called Pig Latin. They still are a wee bit slower than well-written Java, but they're only about 10 or 15% slower on average than a well-written Java. Even if I'm a Java developer and I understand how to write MapReduce code and how to write Java, I probably still want to write my queries in Hive or Pig. By contrast, a job that would take about an hour to write Java code for could take simply 5 or 10 minutes to write the equivalent Pig or Hive for. Impala is somewhat of a different beast. It's actually a completely separate set of daemons that runs in the cluster. The user interface that you use to run queries is essentially a subset of HiveQL. It's meant for low latency interactive queries. At this time, it's only formally supported by CDH 4.x, though many have gotten it to work in other clusters. One thing we should really call out is that Hive and Impala are especially good for analytics, while Pig is really good at doing ETL or processing. Hive can be installed on each individual client, or it can run as a centralized web service via the Hive 2 service. It was developed at Facebook, which probably means the Facebook folks are a lot more comfortable in a SQL environment than a Dataflow language environment. Its SQL-like language probably makes it the easiest one to learn, but it does require a metastore to provide a sort of Hive table to underlying HDFS data mapping. We cover this metastore when we take a detailed look at Hive in other decks. Pig, again, can be installed on a client or run as a web service. It was developed at Yahoo, and it uses a data flow language which is particularly well suited to extract, transform, and load, or ETL operations. It really requires nothing besides the Pig interpreter. And again, just like Hive, it takes these Pig Latin scripts, converts them into a series of MapReduce jobs, which then run in the cluster and give us some output. Impala, again, is a separate set of daemons in the cluster, whereas Hive and Pig both require the job tracker and one or more task trackers running in the cluster. Impala requires an Impala D daemon, which is run on each slave node. Again, with Impala, we could turn off the job tracker and the task tracker, and the Impala queries would work just fine because they use these different set of daemons. There's also a centralized state store D daemon, which runs on a single machine. Typically, we'll put it on one of the master nodes, and we have one of these running per cluster. We cover both of these daemons in more detail in the Impala Deep Dive deck. Impala was developed at Cloudera, but it is open source and 100% free to use. It is, however, not fault tolerant, and it does have some limitations, like it does not allow us to use user-defined functions, and it is a subset of the HiveQL language, which means it doesn't support HiveQL 100%. Let's take a look at some of the use cases. Again, we'll probably want to use Hive when your data maps well into row-column formats, as we see with table data, or when your data analysts are SQL pros. Hive is pretty much a no-brainer. You'll want to use Peg when you're performing complex ETL operations, or you're performing complex data flow language. Although it's up for debate, I'd argue that Pig gives more control than Hive does. You want to use Impala when your data maps well into row and column formats, and most importantly, you need real-time interactive querying capability. When using Hive, you're still limited by MapReduce, and although the language is very easy to write, you're still going to be waiting seconds or minutes for a response. With Impala, you're using essentially the same language as HiveQL, and you're getting responses back, sometimes sub-second or a few milliseconds. When you're using Impala, you want to make sure that the lack of fault tolerance is acceptable. Typically, if you're just doing interactive queries, if a query fails, you just run it again. And you could run 10 or 20 of those queries in the time that it would have taken the HiveQL to complete. Looking at each of these technologies side by side, the run model for Hive and Pig is MapReduce. We need a job tracker and one or more task trackers running in the cluster, whereas Impala's model is real-time. Cloudera says that Impala makes SQL a first-class citizen, and these individual state store and Impala D daemons make sure that the query completes much faster. Because Hive and Pig are both using MapReduce, they're both fault-tolerant and relatively slow, whereas Impala is not fault-tolerant and extremely fast. Among the three technologies, Hive is probably the easiest to use. Pig is probably a bit harder to use and has a slightly longer learning curve, And Impala, again, being a subset of HiveQL, is the most limited, but is probably very, very easy to use and has a very minimal learning curve. You can use all of these three technologies together. Many developers will use Hive and Pig alternately back and forth, depending on the type of query they're running and what they need to do in that query. If you're building complex workflows where many Hive or Pig scripts need to run back to back, you'll probably end up wanting to use the Uzi tool, which we also discussed in another deck. We took a side-by-side look at Hive, Pig, and Impala and how these technologies can be used independently and together.